Let us look at question number 46 now. Which of the following is a reason for using KO2 in space and submarines? So if we talk about KO2, the KO2 reacts with CO2 to generate oxygen again. So it forms K2CO3 and it forms O2. So it is used in space and submarines because it will absorb the CO2 which is produced and generate oxygen for the people to breathe. So if you look at the options which are given to us, we can clearly see that we have to select the first option as the correct answer. Let us look at the next question. Question number 47. A metal M forms soluble MSO4 and water insoluble MOH whole twice. The oxide of the metal M is soluble in NaOH as well. So based on this information, you can clearly see that the metal M has to be amphoteric. So if you look at the options which are given to us, the metal M which satisfies all the above conditions is Zn. So we have to mark option 3 as the correct answer to this question. Let us look at the next question. Question number 48. Some of the processes are given below. In which of the following process the hybridization of the underlying atom changes? So if you talk about the first option, we have ammonia changing into ammonium ions. So if we talk about the hybridization, both of them are in sp3. So this is not the correct answer. If you look at the second option now, H2O changes to H3O plus. This is also not correct as hybridization of both these species is sp3. If you talk about the third option now, in which BF3 changes into BF4 minus. So in BF3 we have sp2 hybridization of boron, whereas in BF4 minus we have sp3 hybridization of boron. So this is correct, students. In this process, the hybridization of the underlying atom changes. And if you talk about the fourth option, this is also incorrect, students. In both the cases, the hybridization of phosphorus is sp3. So if you look at the options, we can clearly see that we have to select the third option as the correct answer to this question. Let us look at the next question. Question number 49. How many electrons are present in sodium that have n plus L value equal to 3? Where n and L are the principal quantum number and the azimuthal quantum number. Okay. So if you talk about n plus L value equal to 3, we can have 3 plus 0. So we can have n equal to 3 and L equal to 0, which means that we have the 3s orbital. If you talk about the other case, which is 2 plus 1, so we have n equal to 2 and L equal to 1, which means that we have the 2p orbital. So other combinations are not possible for n plus L as there are constraints on the values which L can take. Okay. So we have two different orbitals, and if we talk about the number of electrons present, the 2p is fully filled for sodium. It has 6 electrons, and the 3s has only 1 electron. It is singly occupied. And if you talk about the total number of electrons, you have to mark the correct answer as 7. So for this question, we have to mark the correct option as option 3. Let us look at the next question. Question number 50. MCl4 2 negative is a tetrahedral complex whose spin-only magnetic moment is 3.87 Bohr magneton. The element M is. So if we talk about the mu value, it is given to us that it is 3.87 Bohr magnetons, which means that the number of unpaired electrons present is equal to 3. And we can have either D3 or D7 configuration. So M2 plus should have a D3 or D7 configuration. Now if you look at the other information which is given to us, the examiner has told us that the complex is tetrahedral, which means that the D3 case is not possible, as a D3 will form a square planar complex when it is 4 coordinated. Okay. So the only option left to us is D7. So we have S2 D7 configuration present for M. So it must mean that the metal M is cobalt. Students, for this question, we have to select the correct option as option 1. Let us look at the next question.